Good day. My name is Chaw, Anna, and as you can see on the screen, the topic that was given to me is Chapter 24, Carbonyl Condensation Reactions. Let's proceed. Here in this topic, we learn about four major carbonyl condensation reactions, which include aldol reaction, Claisen reaction, Michael reaction, and Robinson annulation reaction. Here in this chapter, there are also additional reactions or some variation of carbonyl reaction. The first one is directed aldol reaction, where the enolate is prepared with LDA, and then the second carbonyl will act as electrophile and added to the enolate form. Then the reaction continue with dehydration to form alpha-beta unsaturated carbonyl compound. The second one is intramolecular aldol reaction, which involve in the formation of 5 to 6 membered rings. For the mechanism, it involves in the formation of enolate, and then proceed with 2 to 4 steps of cyclization and dehydration. Another reaction that we learn in this chapter is Dickman reaction, which is an intermolecular Claisen reaction of diesters form 5 and 6 membered rings, preferentially due to steric stability. For example, in the formation of 1,6 and 1,7 diesters. These two diesters give good yields of cyclic products. For the mechanism of Dickman reaction, it is exactly the same as the mechanism of intermolecular Claisen reaction. For the first reaction that I chose for detailed presentation for the topic is aldol reaction. Aldol reaction is a reaction between two carbonyl, which is aldehyde or ketone, forming beta-hydroxycarbonyl. Here, for the mechanism of aldol reaction, I'm going to explain for the mechanism of 2-pentyl cinnamaldehyde, commonly called flosel, which is a perfume ingredient with a jasmine-like odor. Flosel is an alpha-beta unsaturated aldehyde made by cross-aldol reaction between benzaldehyde and heptanyl, followed by dehydration. For the mechanism, first step involves formation of a nucleophilic enolate of the heptanyl, where the hydroxide ion will go and attack the alpha hydrogen and forms an enolate. Enolate form then react with other carbonyl compounds, here in this case is the benzaldehyde, to form a new carbon-carbon bond at the alpha carbon to the carbonyl group of benzaldehyde. Second step involves nucleophilic and protonation, and then continue with dehydration to form the desired product, which is flosel. Here I'm going to explain about the application of aldol reactions besides carbonyl compounds used in perfume ingredient as the previous slide. It also involves in biological and pharmacological properties in formation of compounds called as chalcone, which is an aldol condensation between benzaldehyde and acetophenone in the presence of sodium hydroxide as a catalyst. Chalcone consists of several biological and pharmacological properties including antioxidant, antimicrobial, antimalarial, and anti-inflammatory. In addition, chalcones also exhibit excellent anti-cancer activity and attracted much attention in anti-cancer studies. Secondly is danpensil, which also called as or trade name as aricept, is used to treat dementia, a brain disorder that affects the ability to remember, think clearly, communicate, and perform daily activities. In people who have Alzheimer's disease, a brain disease that slowly destroys the memory and the ability to think. Danpensil works to improve mental functions such as memory, to think clearly, and perform regular and daily activities. The second reaction that I'm going to emphasize on is the Claisen reaction. The Claisen condensation is a carbon-carbon bond-forming reaction that occurs between two esters or one ester and another carbonyl compounds in the presence of a strong base, resulting in beta-ketoester or beta-diketone ester. Claisen reaction involves three steps, which is first is the formation of an enolate, where the negative OET from the base will attack the alpha hydrogen and forming enolate. To be informed that the enolate is generally formed from the ketone component, and the reaction works best when the esters has no alpha hydrogens. Second step will involve nucleophilic addition to a carbonyl compound or group, which here new carbon-carbon bond will form between the ketone enolate and the ethyl chloroformate, which is the ester, as shown here. Third step, lastly, is elimination of the leaving group, where in this reaction, Cl- is eliminated rather than the negative OET because Cl is a beta leaving group, and the product will form, which is the beta-keto ester. In application, Claisen reactions are known to be a very useful synthetic intermediates in the field of organic chemistry. Beta-keto esters can be used to synthesize compounds that are of medical and industrial importance. For instance, a series of beta-keto esters was synthesized from ketones and ethyl chloroformate in the presence of base, which in turn are converted to pyrazoles and then subjected to cytotoxicity studies toward various cancer cell lines and antimicrobial activity studies toward various bacterial and fungal strains. Another main application of Claisen condensation is the formation of ethyl acetoacetate, which is used as a reagent for many manufacturing processes in the chemical industries. Lastly, for the summary of this chapter, here in this chapter we learn about four major carbonyl condensation reactions, which include Aldo reaction, Claisen reaction, Michael reaction, and Robinson annulation. We also learn about additional reactions such as directed Aldo reaction, intramolecular Aldo reaction, and Dickman reaction, which involve formation of 5 and 6 membered rings strictly due to steric hindrance. Specifically for Aldo reaction, we take the formation of flow cell as example, where we learn about its reaction condition that involve base as solvent and mechanism that involve two steps, where the first step involves the formation of enolate, then continue with nucleophilic addition and protonation. Secondly, we learn about Claisen reaction that involve in the formation of beta-keto ester in the presence of strong base. For the mechanism, it is simply involved three steps, which is first the formation of an enolate, second nucleophilic addition to carbonyl group, and then the third last step is the elimination of a leaving group. And that's all from me. Thank you.